Okay, thank you, everybody. Today we have Mars Land with us. He is the co-founder and CTO at Metadata, and his talk today is entitled "Metadata is the New Refinery." Thank you.
It's a pleasure to be here, and thanks, Diane, for inviting me over. Diane and I went way back. We studied UCLA together for our PhD program, so we knew each other for more than 10 years at this point. And actually, coming back here brought back a lot of memories. I didn't go to USF, but actually work just across the street from here at a little company called Google. This was also a long time ago, but it does bring back a lot of nice memories. Commuting from South Bay to the city every day. It wasn't fun. So today I'm here to talk a little bit about, as you can probably guess, metadata. And some of you might have questions about what that means and why do you talk about metadata in the data seminar. The two related. Hopefully I can display some of those today. All right, a little bit about myself. So yeah, as Victor introduced, I'm currently the CTO and co-founder at a company called Metadata that I and my co-founder started about 2 years ago. Prior to that, I was at a company called LinkedIn. Some of you probably heard of it as well. And I was a tech lead there for the team, incidentally metadata team as well. And like I mentioned before, prior to that, I was at Google for a couple of years. And prior to that, I was with Diane at UCLA studying CS. All right. I want to see a show of hand. How many of you have seen this article or heard of this quote or seen this picture before? Can I see how many of you? About half of you. The other half, I don't know why you joined this program, to be honest. No, just kidding. But this was quoted, at this point 5 years ago, right, by The Economist, basically saying that what's going to be the most valuable resource going forward is not oil but data. Right? And obviously, that is a pretty bold statement, but you can probably guess by looking at the picture, which other company that The Economist was referring to that was holding the data, thus the valuable resource. All right, here's some empirical proof that data is actually more valuable than oil. If you look at the trend, the red line represents the search on Google around the world, by the way, not even limited to the US. And then the blue line represents the word data science, okay? And you can see this started getting more and more valuable over time. So you are all in the right program, by the way, so be happy about that. And if data is the crude oil, okay, that's all well and good. What is metadata? Metadata is the refinery, okay? It's a thing that turns your crude oil into something that's actually useful. Crude oil itself, if you're not aware of, is actually very, very useless. You have to turn it into plastic, turn it into petroleum, gas, and all that sort of stuff to make it useful, okay? So, which is basically implying that metadata is as important, if not more important, than the data itself. So up to this point, I probably used metadata more than 10 times in my talk. So what is metadata? I'll let Mr. Leonardo explain that to you. Okay, metadata is data about other data, okay, or data about the data. Okay, but what does that really mean? All right, metadata 101. This is probably as simple as you can get as a data, right? Okay, spreadsheet. All right, we're all familiar with spreadsheet. Couple of columns. We even have the title, which sometimes is rare. You may not even have the title. You have the values in there. Okay, but can anyone guess what this data is about? You have a very generic ID, okay. Get some name, but it turns out to be a month's name, maybe. You have date, okay, but what does this date actually mean? You have values, oh, okay, integer value maybe, but some null value in there. So when you are handed something like this, you'll be scratching your head and be asking the typical question, right? When was this last updated? Okay, who created this anyway? What does each column actually mean? I understand what ID means. I understand what name means. I understand what date means, but I have absolutely no idea what it means. Where did this data even come from? And how is this value computed here, right? And what the hell is there actually null value in this column? All of these questions, and the answer to these questions is essentially metadata. So think of it as context about your data. And without it, actually data kind of become kind of useless at this point because you just don't know how to use it, just don't know what it means. So that's metadata right there. All right, then we'll get into the type of metadata that you can have. And I'm talking about this in the general company enterprise context, but you can sort of extrapolate that into maybe your other context, government and schools or whatnot. But you start with the first kind of metadata that people are probably most familiar with. It's generally called technical metadata. Right? So this is essentially answering the question of what is this thing actually. Think of it as things like, okay, a structure, right? Okay, am I looking at a database? Am I looking at a schema, or am I looking at a table inside a schema inside a database? And what the columns it has, and so on and so forth. I'm assuming some of you guys will have used MySQL or Postgres or Oracle, one of these databases, right? You'll be very familiar with this concept because this actually just means information schema. If you think about it, you go query, what are the tables that you have in the system and what are the columns they are and what data type it is. That's literally what this thing is about. All right, and then the next thing is actually less obvious. It's lineage. Okay, what that means is essentially where does this data come from, and that's on the upstream side of the story. If you look at downstream, that's basically where is this data going to, right, so to speak. So who's my grandparents and who are my grandchild, so to speak. And why is this important? Well, it's absolutely important, once again, in the context of a real complex data ecosystem inside a company, because you have millions and millions of tables, and you have millions and millions of jobs that's deriving one table to another table. That's basically what the data ecosystem looks like in the company. So if you don't know where your data came from, it's become very hard to understand how it was computed. Once again, going back to that spreadsheet example, just giving you the value itself is not going to help you. All right, and then last thing is also, I think as a data scientist is one of your favorite, right? Whenever you were given a data set, the first thing you do is, let me take a look at the distribution of the value, right? Okay, there's a Boolean field, okay, how many true false are there? All right, it's a numeric field, let me see the histogram of it, so on and so forth. You want to kind of feel how the data looks like or shaped like. That's basically data profiling, right? So all of these things, if you notice, all of these kind of metadata, they're all kind of factual, essentially. A table has 5 columns, and these are the name of the column. These are all factual, indisputable, essentially. If you can query the system, you get those values. Right? Likewise, data profiling, same thing as well, right? You run the query, you get the profile, that's it, right? There's nothing to dispute about that. So these are basically the nature of technical metadata. And this is where a lot of people put emphasis on and focus on a lot, which is, by no means it's important. But this is actually not the most complicated thing, because like I said, this is all factual. If you have access, you can look at that, you understand. The next bit of metadata, the next type of metadata is called business metadata, okay? So essentially, trying to answer the question, why the hell did you have this table here in the first place? And in the context of a company or enterprise, is generally because it ties to some sort of business goal, right? If it's your BI, then maybe you're computing some sort of metrics in order to, understand how the company is doing, or whether the product is doing good or not. If it's in a case of data science, okay, well, the data set exists because I want to create my models, machine learning models and whatnot to drive something. There's always kind of a business reason behind the data. You never just have data for having data's sake. There's always a goal behind it, right? But then this part gets interesting because this is not written anyway, right? If you crack open your data set or if you crack open your tables, it's not going to tell you what it is, why it exists. This sort of thing generally exists in some sort of auxiliary form, right? Okay, someone has a README file somewhere, or tribal knowledge. Someone tell you, hey, we had this because of X, Y, and Z. And this, like I mentioned, is a lot of them is to do with the business metrics or business glossary, business dictionary, if you're familiar with some of those terms. And a lot of time is also about how do you map a bunch of data back into some sort of business group or organization or hierarchy. So on. All right, the third type of metadata is even more elusive, right? Because the second type, you can actually go and ask someone, and you can probably get it. The third type is almost implicit. These are things about how and where and who is using the data in the first place. All right. Some of these you can glean from various sources, right? For example, if you want to know what were the queries issued against a particular table, you can probably go to the query logs and you can figure that out, so to speak. Right? But things like ownership is actually sounds very simple, but it's actually a very tricky question. Because data is generally considered like a commodity inside a company, right? Nobody truly owns it, right? Someone's in charge of building the pipeline to create the data. Someone's, probably very familiar with it because they use it to build their use cases on a daily basis. So there isn't really a single person who's an actual owner of the data. It's depending on what context you're asking. And finally, there's a lot of conversation inside of a company. Right? These are kind of your tribal knowledge. People talk to other people and say, oh, how do you use this? Oh, yeah, I did it last year. This is how I did it, et cetera, et cetera. A lot of this tribal knowledge is not captured anywhere, right? Probably in somewhere in your Slack or maybe somewhere in your email message, so on and so forth. But those are super critical, right? Remembering the spreadsheet example once again, right? Those are the answers to all the questions that you have about data. So hopefully that explains the type of metadata that we commonly see in a company. So now you'd be like, okay, so what? Who actually cares about this thing, right? Who should, what, and why should we even care about it at all? Okay, so the first group of people generally are sort of known as the data consumer. Right? These are your data analysts, your business analysts, your business user. These people are kind of on the consuming end or using end of the data, right? Maybe they look at a dashboard, maybe they look at some sort of metrics and so on and so forth. These people, the common question they want to ask is, there you go. So the question that they typically ask is, I don't know what the company has in terms of data, right? Or even if I found them, I don't know how to use them. And even if I find it, I don't know if I can trust them. Because if there's no history around it, I just don't know how to use this thing at all. So what happens generally is these consumers will go to the so-called producers. All right? These are generally considered the data team, the core data team inside a company. These are data engineers, analytic engineers, and so on and so forth. These are the people who bring in data from outside or from product and then try to massage it, put it into standardized form, et cetera, et cetera. And these people don't like it, right? They'll say, hey, look, I'm hired here to write code, here to write queries and whatnot. I'm not hired here to support these people, right? And then in fact, it's not just because they don't like supporting these people. They don't know how to support these people. Because a lot of time, the knowledge about the data is tied to the business itself. And then the engineers themselves generally don't have any concept about that. Right? They say, well, I was told to ETL, bring the data from Salesforce and from Google Analytics and all that. I have no clue about what's in there. I just know I bring data from Salesforce and that's it. I don't know how to interpret that. So don't ask me about it. I know the data. If you want a Salesforce table, here's the Salesforce table. So these people are not happy either. And then finally, if you look at the sort of the executive level, higher level, head of data, or chief data officers and whatnot, these people, they care a lot about the investment. we spend so much money in people, infrastructures, et cetera, et cetera. Are we getting any sort of real ROI out of this? And also, I was promised that if I buy the system XYZ, I can completely make this system self-service. Right? No one will have to ever come to bug anyone. They should be able to just use the data at will. But the reality is not. These folks are talking all the time and complaining all the time. It's not solving my problem. All right. So the next question is, all right, it sounds like a reasonable issue, but why now? I mean, this problem would have existed forever. Whenever you have data, you have this problem already. And why should we care about it now? Why is it an issue now? Why isn't there a solution? So I'll talk a little bit about what happens in the past decades or so in data. The first thing is, every company is trying to achieve this nirvana of data democratization. Right? They want to enable everyone who's interested in data able to use the data, make use of the data, and derive more insight. Drive business, data, make decision based on data, et cetera, et cetera. So in other words, what you get is your data ecosystem grows a lot more organically, right? Because you want more people to do more things. You don't want them to be controlled. You want to enable them, empower them. And then the second bit is, it used to be general data title, but here I list all the latest fancy titles, and if you guys are looking for a job afterwards, you'll probably see some of these. Obviously, you guys a lot of you fall into the data science category, but there's something called data analysts, data engineers, analytics engineers, business analysts. So kind of you just throw all those words in any sort of random combination, you get a title there. What does that mean? That means you end up having an ecosystem where you have very different persona coming in and try to use the data in a very different way. You have people who are fluent in SQL, they can write crazy 1,000-line SQL, and I can read it as well. Great. You have people who say, hey, I can write Python, I can write Spark, I can do all these things, I can do notebook and all that. Great. But then you also have, on the other hand, people who say, I don't know anything about these technology. All I do is looking in the dashboard and finding my data, right? And there are people who say, hey, I'm just an exam. I don't even look at dashboard. I ask people to look at dashboard, tell me, so I put that into a PowerPoint so I can present it to the board. Right? So you have all sorts of different people who are trying to interact and collaborate and play the data ecosystem. So more personas. And most of you will probably hear of a lot of these systems here, and it feels like every quarter, maybe or even every month, there's a new open source data set that comes out that promises you X, Y, and Z. Right? And the reality of it is, most companies, they end up picking up many of these specialized data systems, right? Because they need them. They have for specific purpose, whether it's for analytical workflows or for transactional workflows, or for slice and dice, for real time, et cetera, et cetera. So your ecosystem is no longer simple. It's actually get a lot more complicated. And on this one, it should be a no-brainer. Like every company is trying to move to cloud. If they're not moved to cloud, they're in the process of moving to cloud. What does that really mean? It means compute becomes very cheap, storage becomes even cheaper. You get more and more data. And people are very happy to create data. No one's want to delete anything because the cost of deleting is higher than the cost of creation. So just create more data, store more data. If it's just 1 to 4, that's still okay. It's a matter of scale, right? Okay. Fifth is a very interesting one, and many of you will probably heard of this already, because it's not all unicorn and rainbow. Just do whatever you want in data ecosystem. A lot of companies are subjected to increasing regulatory pressure. Right? Things like how many of you heard of the law GDPR? Hopefully, most of you do. If you're not, you will. I guarantee you. But it's not just GDPR. If you look at these, it's essentially a whole bunch of 4-letter scary things. GDPR, CCPA, LGPD. This is Brazil, I think. This is China, PIPL. I don't even know what this is. A bunch of them. Right? There's a whole lot of new laws come in and say, hey, look, I don't want you to just play with the data. And really, I want you to actually respect your users. I want you to protect people's privacy and so on and so forth. So on the one hand, you want to enable anyone to do anything with the data. But on the other hand, you say, oh, wait a second, we cannot do that because we'll be breaking the law, right? So that's put some control in it. So this is where things get really tricky. So what does that really mean? In terms of problem, right? The first problem we hear the most often is finding data is hard. This might seem silly, but it's actually the reality in most companies, right? Most of the data scientists or analysts, if you ask them how they spend their time, on a daily basis, easily 20 or 30% goes to, let me find the right data in the first place. Right? And that's not because there's a lot of data, I cannot find it. It's like, I just don't even know where to start. Right? And there's there isn't like a Google thing there where you can just type in and magically you find the data that you want inside the company. And then the second thing is, okay, yeah, I found the data, but how can I trust it? I don't know how I will be able to trust the data, even if I manage to find it. And here are some of the things that if you don't have lineage, if you don't have data quality, if you don't know the shape of the data, if you don't know who created this data, how can you trust it? Right? I mean, it's impossible to trust it. Once again, if you guys throw in a spreadsheet like what we had before, how, without any of those contexts around it, would you go ahead and start, having your career depends on that spreadsheet, nameless spreadsheet? Right? It wouldn't, right? That wouldn't make any sense. And then on the other hand, because of all these, new laws coming in, privacy laws and whatnot, managing data also becomes a lot harder. Right? And then at the same time, trying to enable these people, allow them to be as productive as possible, but then put in the right kind of guardrail around it so people don't fall off the highway, so to speak. So that is why managing this also becomes hard. How are we doing with time? Okay, good. All right, so now I'll talk about my personal experience. I spent about 4 years at LinkedIn, and pretty much that entire 4 years was correspond to LinkedIn's metadata journey. So I would like to talk a little bit about that. And this will demonstrate to you how most companies will end up going through these phases and why metadata matters in those cases. So this started around 2015, 2016, okay? So this is kind of the early days of the data team at LinkedIn. This is the time when they start realizing, actually the ex-CEO of LinkedIn, Jeff Weiner, famously quoted saying, LinkedIn is not a social network. LinkedIn is a data company because they make money from data. They don't make money from social. And this is a time when they start growing the data team very rapidly. And it's a little bit ahead of everybody else, so to speak. And that's kind of the typical things, big tech started something first and then everybody else said, oh, this is a great way. That's all Russian. So this is the early day of big data, if you will, at LinkedIn. And the focus was mostly on so-called search and discovery. Right? I don't even know what we have. So let me help you to find what we have inside of LinkedIn. That's the first order of problem to solve. So there's a product created called Warehouse, and it's a pun on data warehouse. Get that? I didn't name that, so that's why it's so bad. Just kidding. Prior to me joining LinkedIn, they had this project called Warehouse. It's really a very, very simple search engine, if you will. So essentially it goes to various systems inside of LinkedIn and grab all the tables, and then just index it. And then someone can type in and say, oh, I want to find a table named food, and then you get all the food table, so to speak. So that's kind of what it is. Very simple app. I often joke about that. You can probably get a new grad who work on this, and then it will do a better job. But it's literally where the starting points of all these. So I joined LinkedIn at around this time frame, 2017. And pretty much the second week I joined LinkedIn, I was told that drop everything, forget about what you're doing. There's only one thing that matters, which is GDPR. And why is that? Because LinkedIn used to be a very democratized ecosystem, you put it nicely, but the reality of it is very uncontrolled, right? And now all of a sudden, the European Union comes with a big hammer, GDPR, and say, if you don't follow law, I'm going to fine 4% of your global revenue. And LinkedIn did a calculation and said, wait a second, we're now part of Microsoft. So 4% of Microsoft's global revenue is more than what we make as a whole company. So that is why all of a sudden this becomes very, very important. And LinkedIn decided to take a complete metadata-based approach. Right? Some company took a very different way, but LinkedIn decided we're gonna use metadata to solve this problem. So all of a sudden my team becomes super important because I'm the only metadata team in LinkedIn. So we become the team to solve this problem for LinkedIn. And then this is a time when we realized the old warehouse no longer works anymore because it's just a little app, dingy app. So we got to really build something that is scalable to solve the GDPR problem for LinkedIn. And we named that thing TMS. Will anyone try to guess what TMS stands for? No? I came up with that, so this is good. It's called the metadata store. So it's kind of essentially your typical 3-tier web service. You have the web, but then you have the backend. The backend has API, and the API is scalable, so you can service all these programmatic requests. You delete data, etc. Okay. So that's all well and good. We solved that problem for LinkedIn in about 1.5 to 2 years. Now comes the next phase. So all of a sudden we realized something interesting here. We solved 2 use cases using metadata at LinkedIn. The very first case was search and discovery. The second use case is compliance. And then the 2 use cases actually overlap heavily in terms of the metadata. Actually, in fact, I'll say probably this is like 10–20% extra metadata from this. Okay? And then the light bulb went off in our brain. We realized, hey, wait a second, this thing seems very important and seems like there's some legs to it. So we decided that we're gonna blow up what we built here during this phase and rebuild version 3. And we call that Data Hub. So what it does is literally is a generalized metadata platform where we can gather a lot of any sort of variety of different kind of metadata into the system, able to index them and serve them back, serve through APIs and whatnot. And so it becomes a platform at that point. It's no longer just an application to solve a particular use case. It becomes a platform that can solve pretty much any metadata use case you want to solve at it. And we actually also open source it, so you can find it online as well on GitHub if you want. It is the #1 open source project out there in this field today. So by far, if you look at the GitHub stars. So that's what we did at LinkedIn. And then 2 years ago, my co-founder, who happened to be the manager of the team, I was the tech leader of the team, we decided we want to leave LinkedIn and start a company around this and solve this problem for many other companies, not just LinkedIn. And that's when we created Metaphor. A lot of what we did after we left LinkedIn is fairly similar to what we did at LinkedIn, but we re-architect the entire system from the ground up to essentially provide cloud-native SaaS service for the rest of the companies out there. And just to give you a sense of, when I say this became very useful at LinkedIn, just to give you a sense, when I left LinkedIn, this is basically what Data Hub looks like at LinkedIn. So obviously, we are still the backbone of the data privacy compliance at LinkedIn. It was integrated with 40+ teams and projects inside of LinkedIn. And we have 30 different kind of what we call entities, and these are basically different type of things that we track metadata on. And there's over 200 types of metadata that we're tracking. That's about 2,000 weekly active users at LinkedIn, which is actually by far probably one of the top internal apps at LinkedIn. And also not just that, there's a whole bunch of additional use cases beyond our original search and discovery that was also solved through metadata. ML DevOps, I won't go through all of them, but you can read the list there. Right? So there's a whole bunch of other use cases that got opened up by the virtue of having metadata consolidated in one place. So in the beginning, I talked about Refinery. This is how the Refinery looked like. So on the one hand, you have various things that basically produces metadata. I don't know how many of you recognize all these logos, but if you haven't, you probably should. Snowflake, dbt, Databricks, Looker, FastSpot. These are some of the systems out there that every company or a lot of companies are using. Okay. So all of these systems, they have metadata, they generate metadata. The metadata basically get gathered or pushed or pulled into the platform itself. Okay. And on top of that, we have all these business metadata, if you remember, we talk about these enrichment that you bring in from the other end into the platform as well. And on top of the platform, you basically try to solve all these various different use cases. But if you crack open the platform, at a very high level, there's kind of a couple of pieces. You want, your typical API services that basically able to serve these metadata back. And then there's generally a very graph-oriented nature to metadata. This thing's related to that thing, and this thing produces that, and someone uses this and all that. All these are basically kind of a graph-oriented model. And then finally, you also want to be able to regurgitate back all these metadata to whoever want to inquire into the metadata. So think of this as a metadata warehouse. Where you can basically slice and dice and query and join all various metadata through the most universal language, SQL. Okay, so yes, there's the platform piece. We understand that. But then it's actually beyond, it goes beyond just the platform piece. Because if you think about it, on the one hand, you have the producer there and consumers and their boss, different kind of metadata that's coming into the system. Right? And also various systems is integrated to. And you want to also be able to surface these metadata back to whether it's human or programmatic access. So obviously there's going to be a web. There's going to be some sort of web portal that people go to and all that. But that's generally not enough. Because what happens is most people do their work in Slack, surprisingly. Right? That's where most people do have their conversation, do their work and all that. So you kind of have to make sure that the metadata is surfaced in that sort of context. And then not just that, there's going to be a lot of different applications people use inside a company, not just your application. So you want to make sure that it is, you're able to surface this metadata, if they're looking at a Looker dashboard, right? Or if they're doing a Jupyter notebook, whatever they do in browser, you want to be able to provide them very, very helpful metadata and at that point in time. A good example would be if someone is typing out in Jupyter Notebook and then you say, oh, okay, I'm coding at the same time, but I was, oh, I wish I know what this field actually means, right? Because I'm pulling in from this bigger data. Right? It'll be very, very nice if you have essentially kind of like the VS Code IntelliSense capability where it just pop up and say, oh, by the way, here's the documentation. Oh, by the way, and that guy or girl from the next team, he or she did an analysis on this, 2 weeks ago. You go and talk to them about it. So that is where the real metadata power of metadata is. Right? It's not consolidated in one place, but distributed to wherever it's needed. And then finally, application, based programming-based access of metadata is almost a must. It's almost a no-brainer. A lot of companies, they want to be able to integrate a CI/CD pipeline with the metadata itself. For example, if you change a single line of code, SQL or whatever, you want to be able to know what's the actual impact of this, right? And then you'll be surprised is that 1,000 tables get impacted by your one line of code change. You want to be able to know that before you check the code in. So that's just an example, one of the many examples you can do for this API access. All right, that's coming to the end of my talk. So if you didn't hear anything I said at all, just pay attention here. This is the only thing that matters. In real estate, there's a saying that there's only 3 things that matter in real estate. Location, location, location. That's the only 3 things that matter in real estate. So next time when you buy a house, think of that. And I'll turn that around and say the only thing matters in data is data. Thank you.
Okay, now we'll take questions. If anyone has them, please line up. side? Yes, go ahead.
So if the data engineer is using the Metaphor data platform, do they still manually typing all the information of like the columns or?
So, obviously this is not a talk about Metaphor, but yes, of course, any good metadata system should be able to bring in all existing metadata from systems, right? And a lot of systems support putting description in the system itself. For example, Snowflake will allow you to add a comment to a column, right? Or a table for that matter. You want to definitely bring those things in, right? Because you don't want so much duplicated work. That's first thing, okay? But then generally that is not enough, because guess what? If you have a table and then the column name is called first name, will anyone venture what the comment will be for that column? First name. There you go. Not very helpful, right? Because whoever created the table doesn't have the use case in mind at that point. Right? Whoever created the table say, oh, I pulled this data from this place, right? So it's first name, first name. I'm not gonna say, by the way, if you're doing use case XYZ, you have to filter all these first name by against the location columns, because that's the one that that's the part that matters. Right? Or maybe there's a type column. Make sure you filter out all the type. You're not going to say any of that in the system, right? Because that would be strange. You're kind of limiting yourself to just that use case. But once you bring it into a catalog or web or whatever you want to call that, web portal, you want to allow people to add these use case specific comments to it. Right? Because that's what people care. They don't care about the first name columns called first name. They don't even care about if it's a customer's first name. That's still not helpful. I need something very, very specific about the use case I'm talking about. And these sort of things don't belong to the system itself. That would be very strange. Even if you want to push it back to the system, that would also be a strange thing to do. I hope that answers your question.
Yeah, can I do a follow-up? Sure. So if someone tapping the information with this specific field and someone else tapping another table of this field, this actually correlated, they're the same thing. But when they type in the metadata, they type in something different of describing this. Can it be identified that they're actually the same?
Yeah, absolutely. I mean, the reason why you bring metadata into one place is to answer these very tricky to answer questions. Right? So, for example, I'll even take your question beyond that. Right? You have two complete different tables, but guess what? They're duplicates, right? Because somewhere in the past, someone make a copy here, and then later on, 3 days later, this second person didn't know the first table exists, create another copy, right? If you do not have a global view of what you have in the system, then you will not know that. And you can take it even one step further and say, maybe it's not as trivial as exact copy, right? Maybe they are similar, but not quite the same, right? And how do you do that in that case? Well, you can do similarity search, clustering. We can do a whole bunch of magic, around it to identify what's duplicated. But it's only possible when you bring all of them to one place.
There is, thank you for the great talk, of course. There's one question online. Is Metaphor a SaaS version of OSS Data Hub?
The short answer is no.
OSS.
Open source.
Okay.
Yeah. The short answer is no. Despite Data Hub being a great open source project, it was still kind of designed for LinkedIn specifically, right? We built it inside of LinkedIn. There was a lot of constraint about what can be used and what cannot be used in the company. So when we came out and started Metaphor, the first thing we decided is we're going to rewrite the whole thing from for two reasons. First of all, we being a company, of course, we try to make money. We're trying to survive. So we want to make sure that it's a system that's scalable and you can do things like multi-tenancy and all that sort of stuff. Obviously, inside of LinkedIn, nobody cares. It's always single tenant. Right? And there's also a lot of great cloud technology we could have leveraged inside of LinkedIn, but we couldn't because LinkedIn wasn't cloud native. So that's why we decided to rewrite the thing. And then we also joke about, we know exactly where the skeleton is because we put the skeleton in the first place. So when we have the opportunity to rewrite, obviously we try to learn from our previous mistake and build a better system.
I have two questions. One is like sometimes the data teams or the company doesn't have a documentation about the table or the metadata. It's one of the company's work is like finding this hidden relationship and the metadata from the existing data, as you mentioned, like first name. How do you discover it? Just I'm curious, what would be the technology to use to just untangle and bring it back to life?
Yeah. So lineage is one of the keys here, right? I didn't get deep into it, but lineage is actually a very interesting field. And by lineage, we're talking about generally called column level lineage, right? So you actually want to know, it's not good enough to know, hey, this table came from the other 3 tables. You actually want to know which exact column did this column come from and what was the actual transformation you did when you bring that over. Once you have that, there's a lot of nice property around it. For example, description will be a good example. You know, if the column get carried from table to table to table without transformation, guess what? The description should not change. Still first name. Right? Of course, when there's transformation involved, then maybe not. We don't know. But when there's no transformation, you can actually carry a lot of these documentation around, which makes it easy for someone to bootstrap a system like this. But the other thing that we experimenting at Metaphor is actually we're using NLP to basically analyze companies' chat histories in Slack or Teams or whatever system they use, and use that to glean what are the important documentation. Right? Because guess what? When people talk about it, is they mention the table, they mention the column, they still talk about something about the data. Right? It's not just random chat. And you are able to actually, in fact, I believe 2 of your students will be joining us very shortly to start embark on this journey of basically doing NLP analysis on chat history to be able to derive useful knowledge.
One last question. This is related to career. I'm curious, and every year students come up and ask me about this question. So some ask, I want to start my career in a big company, like you have years of experience at Google and LinkedIn, and then I start my company or join a startup. And I want to see, and then you also saw many people who start their early career in a startup and then joining a Google and LinkedIn. What would be the pros and cons, or what is the learning trajectory from 2 different experiences?
Yeah, great question. So the first piece of advice I'll give is don't do startup for startup's sake. Okay. That would be the wrong thing to do, startup. You don't start a company just because you want to start a company. And the reality of it is that the odds is against you. No matter how smart you are, no matter how great a team you have, the odds is always against you. So you have to go into a startup, starting a company, right? Joining is a different thing. Starting a company, you have to basically have so much conviction in your ideas, or at least this area that you really like, you want to tackle. Even if it doesn't pay. So can probably give another talk about how we started a company. That's a very interesting story there as well. But if you really, okay, on the other hand, if you really want to do this company, I know some people say, hey, look, I just want to do startup. The right way to do that is by starting something on the side. You can join a big company or small company, it doesn't matter. Right? If you're interested in whatever, right? In machine learning, okay, I'm into stable fusion. I really want to do stable fusion. Then just start with some pet project on the side, right? Open source it, get feedback from people and all that. Just play with it, and you never know, it might actually go somewhere. And then at that point, it's never too late to start a company. So that's the first piece of advice in terms of starting company. Joining startup obviously is a very different story there. So joining startup versus joining big company. Once again, it's case by case. I know a lot of people will thrive in big company and will never want to leave big company. And there were people who just hate the guts, right? As soon as they join a big company and always want to go to startup. But one universal thing we've seen a lot is if you started from a startup, especially if you're early stage employees, and later on your company either get bought out or it didn't work out, you join a big company. Most of the time it doesn't work. Most of these folks will join a big company and work for a few years and leave very early. The reason behind that is once you have the taste of startup, it's very hard to go back to a big company where things are a lot more rigid, a lot more controlled, slower pace, and all that. So if you enjoy that sort of thrill, it's very hard to find the same thing inside a big company. Likewise, it's also a similar story, plenty, but not as prevalent, right? If you use the big company style working and then you go to join a startup, you might also have culture shock as well, right? Because you realize things move a lot faster, it's a lot strappier, and so on and so forth, and you may not like it. But I do feel like it's always about learning, right? And if you have the opportunity, I'll encourage you to do both. The order probably matters a lot less than what you can learn out of both. And you'll learn very different skill set from so yeah, and you're in the Bay Area, right? So you got plenty of opportunity. If you don't like where you first job you landed, you can just quickly find another job next. So I wouldn't be too concerned about making your initial pick and then stick to it. Can you hear me?
I really liked your talk, and while you were speaking, I kind of had flashbacks because there were like times when to find the meaning of few columns, I had to venture out for months, and sometimes the reason why you can't find a meaning is because the person who knew about the table left the firm.
Absolutely.
So with this context, I wanted to ask: so for legacy companies which already have, let's say, thousands or millions of tables, how does one get them started on this journey of metadata? And the second question is that for a lot of, let's say, when there are thousands of users of data, does the metadata warehouse also track who uses the tables and where they're used, so that any changes to the original table can be notified or something like that?
Yep. So let me try to answer the first question. And the analogy we often give is, some of you can probably relate if you are just graduated from college. If I go to your room at your house now, you probably won't be a pretty sight, right? Or your house. But that doesn't stop you from cleaning it, essentially, right? And the way to clean up a messy room, actually, guess what? If I start doing it, there's no other ways around it. It will not magically fix itself. So, but if your task is to clean up your messy room, the last thing you want is to say, I'm gonna set a timer and in 10 seconds, I'm gonna clean up everything. That's not possible. You're gonna set yourself up for failure in that sense. You basically start with the easy one. Okay, maybe let me pick up the trash from the floor. That's easy. All right, now the floor is clean. Let me go and fold my clothes. Right? So you start gradually getting harder, start doing harder and harder things. So you feel accomplished along the way. Right? You don't feel defeated at the beginning. So likewise, the exact same thing here. LinkedIn is a great example right there. Right? They started with a very messy house, but because there's a driving force of GDPR, they say, okay, we can no longer afford to be messy. Right? We have to do something about it. And then it started small, and then start ramping up, and then eventually they get to a nice place. So, but a lot of these require, especially in big companies, kind of require top-down pressure, essentially. Right? The decision has to be bothered by almost at the highest level. At LinkedIn, at the time, the CTO is called Igor. He left and joined Google afterward. So he famously said one thing, right, to all his staff. He said, I have 1,000 people reporting to me. These are data scientists, engineers, and all these folks. And if we can only do one thing this year, I hope we can do two things. But if we can only do one thing, that's not easy. That's the determination it takes. Because corporate generally there's a lot of politics, right? And people don't want to use up their political capital if you don't have. And something like this sort of magnitude, kind of require entire company, right? Or at least on the engineering side, so to speak, on the data side. So you cannot rely on a person, single person's will to make that happen. It's just too hard. So, and actually, there's a second question there too.
I asked that for metadata, do you also track what are the users so that they can be notified in case there were changes?
Got it. So yes, I think I didn't quite show it in the picture that I thrown up there, but essentially the metadata platform itself has many components. Right? And one of the critical component is this, push, for lack of better word, push notification essentially. So because now you have all the metadata coming in, you can actually trigger off a lot of downstream things. A very good example, like what you mentioned just now, the flashback, right? If someone leaves the company, guess what? Something needs to be done about it. For example, if this person was assigned the most knowledgeable person on this table, guess what? This person is gone. Who's the next person? Right? Who was the person that actually took the baton over from this person and start carrying, become the next subject? That needs to happen in a timely fashion, because guess what? The next person might leave in another 3 months or 6 months, who knows, right? Likewise, in the case of GDPR, LinkedIn, there's a lot of that as well, right? Okay, so something get changed, right? And then you gotta start locking down access, for example, or you start opening up access and all that. There's gotta be a lot of downstream treatment.
Thank you for your talk. I would be more interested in how
we can hear you, but I don't think it's answered. Maybe not for the online folks.
Hello. Oh. Again, thank you for the talk. I'd be more interested in how do you sort of capture and process what you mentioned, tribal data in the business and behavioral metadata. If I'm not entirely mistaken, that's something closer to what people will say context. For which some people may argue it's better to sort of kind of feel it. How do you sort of deal with those things from a data science, I guess, perspective or method?
Yeah, so I think I kind of mentioned that before. A very rich source of information is from sort of the chat history. That's what we found, because a lot of these things we talk about somewhere in your Slack, in your Teams, and all that. So that's a very rich source of information. But obviously, this is free form. Right? This is conversational, free form, natural language. So in order to bootstrap the knowledge, you kind of need to have a good understanding of what does this conversation is about? What is this conversation about? And which part of it is a question and which part of it is the answers, and so on and so forth, right? So the intern who will be joining us, one of them, I think, will be working on this exact problem, essentially. But I think this probably been talked about in your course as well, right? Machine learning is not a mathematical. You cannot expect just to throw machine learning at every problem and solve it that way. A lot of times it's kind of a human and machine learning algorithm collaboration, if you will. So I'll just give you a very simple example. In this particular context, right? Your machine learning algorithm might be able to, seep through, millions and billions of messages and find, 10, 20, 100, 1,000 of them being somewhat useful, right? But then who's going to be the best judge in that case? Still the human at the end of the day. The machine can give you a score and say this is 0.82, right? It's better than 0.83, but worse than 0.83, but I don't know whether it's actually, which one is actually useful. So machine learning in this case is, think of it as basically almost like a servant, right? Basically going through all the documents and, okay, here you go. Yeah, the one that are probably useful, and then human ultimately say, oh yeah, this is actually very useful. Thanks for finding it for me. Let me store it in the knowledge base.
Just a follow-up question. After you get those data or knowledge, how do you present to a sort of a newcomer through Wiki or sort of or you point to the person that may have better knowledge in this or other ways?
So the surface area is basically what I was talking about. So there is in the case of Metaphor, right? But so with most metadata systems, it's the same. There's always going to be some sort of web portal where you can go and search and find this information. But based on our experience, that itself is not enough, because people want these things in context while they're working, right? Not, we are now being very, very well trained is whenever we hit something whenever we work on something and we hit a problem, we go to Google and search. We're being very well trained in that sense. But it's a behavior change to ask everyone to do the same in the company. Say, hey, if you have a data question, instead of asking in Slack, go to this portal and find it. And guess what? People say, what? I mean, it's quicker for me to ask in Slack. Why would I want to do that? Right? So, but if there's service right there, then when they're looking at the data, when they're analyzing the data, when they are reading the data and whatnot, then it becomes very, very helpful in that sense. Even if at a minimum telling you who else had worked on this data before would have been super helpful, right? Especially because you know who to talk to at least, instead of emailing the whole company and say, hey, does anyone know anything about this? So
Do we have one last question from the audience? If metadata is a database about a database, then what is the most efficient way to store metadata? Table, graph?
very good question. So there's two different school of thought in this area. So there's one group of people thinking, hey, it's graph, so you must store it in the graph DB. And then there's another group of people saying, hey, no, it's graph is, you can derive graph from any database. It doesn't have to be a graph database. And the funny thing is, at LinkedIn, we try both. We started off initially with MySQL database as our main database. And then we realized there's some use cases where MySQL database is very inefficient in answering, mainly the graph-oriented query. So we actually threw Neo4j on top of it as well. And later on, we migrate both to LinkedIn's own technology. One is called Espresso, which is NoSQL DB, and Liquid, which is LinkedIn's own graph database. So when we came out, we did a bit of debate over what's the right technology to use, whether we should keep using graph database and this sort of graph database tandem with relational database. Ultimately, we end up picking Mongo as our main database system. So first of all, Mongo is NoSQL, so it scales really well. Second of all, it's document store. So you can actually store rich document, right? I don't mean in the sense of paragraphs of text, but structurally rich document. So think of it as a complex JSON block, right? Many fields and many different structures and all that. Mongo will take that very happy, use it very, very happy. And in terms of solving the graph problem, so far we have not hit a lot of issue with that really requires a graph DB. So essentially, we present a graphical interface to the application or the user through GraphQL. So essentially, we have a GraphQL API where you can traverse the graph. But ultimately, all that traversal translates into hitting the database multiple times as you go.
Thank you very much.